Hello. This video is going to take off from where we left off on part 1, in which we have a character controller based object with the new input system player input on it, and the character controller input script that we wrote that uses the character actions that we generated. So just to quickly review, the character actions input action asset has a move, which is a composite 2D vector binding for standard WASD controls, a jump, which is bound with the keyboard, and then jump has the press and release interaction trigger on it, so we get send messages from both the on-up and the on-down events. And then the use action has a hold interaction with the hold time parameter set to 2, so we do not receive any messages from it until we've held the use button, in this case E on the keyboard, for 2 seconds. And in the previous video, we went over how the player input send messages behavior functions. And that is that we register a function, or create a function called onMove because the action was named move, and it accepts a parameter type of input value. We process it, we just assume it's a vector2, throw it in there, and move on. So our script sets a move vector, sets should jump equal to true if we're grounded, tells us whether or not we successfully push the use button long enough, and then applies some basic physics to the character here. Anyway, the next behavior on this list, I'm going to ignore broadcast messages, is invoke Unity events. This should look really familiar to everybody that's used the Unity UI system, where when you open up the events tab, we see 3 events that are built in. That's device lost, device regained, controls changed event. I'm going to ignore these for these videos, but these are very useful to find out whether or not your controller got disconnected and whether you should pause the game, find a new controller, or whatever. The defaults array here was generated by our character actions because our action map is called default. So in this array, we have 3 callbacks, or 3 Unity events that we can subscribe to. Move, jump, and use. And from this UI, you can see that it's expecting a parameter type of callback context. That is not input value. So we couldn't simply point the event at the old onMessage receiver. So I am just going to comment all of these out, and we're going to start over by creating a public function. I'm going to call it the same, called onMove, and it's going to accept a input action callback context. This is a really cool type of parameter because it gives you more information about what's going on with the callback than just was it performed, did it just happen. So you can tell when a action has started, when it has been performed, and when it has been canceled, or released in this case. So for the case of onMove, it's very similar to the point where we can really just do vector2 vec equals context dot read value vector2, and then we can just take this and put it here. And now it's the same function. So when we go back into Unity, we now need to go into the events array and add a event to the default callback, or sorry, default move callback, event, whatever. Drag a reference to the thing we want, and then go to character control input, dynamic callback context on move. So now that specific function will be called whenever a context callback is required. So when we hit play, this works the same as it would if we were using send message. Now where this gets really interesting is where and when the onMove callback gets called. So to help do this, I'm going to debug out a few things. The first of which is going to be the onMove name. So when we debug out the other ones, it'll make sense. Then we're going to debug out the phase, context.phase. That's started, performed, canceled, all of that stuff. And then I'm going to debug out the triggered value, trig context.action.triggered. This lets us know whether the action was actually triggered or not, or whether or not we're getting other information from it. Triggered is fairly unique in that it respects all of the interactions, like on hold, on press, on so on and so forth. Whereas if you were just to read the value, you wouldn't know whether or not it fulfilled the condition of the interaction or not. And then value, well, in this case, we can actually just print out and back. There we go. Clean that up. There we go. So now, because I'm using WASD controls, this won't be updating as fast as if you would be using a gamepad, so it'll actually be easier to read. But now when I tap the D key, we should get 3 events here. Started, meaning that the action has just started. Has it been triggered? No. The next event we get is phase performed. Has it been triggered? Yes, and it has a value. This performed line is the part of the callback that you would normally get through send message. This is the one we want to really pay attention to. And then we get a canceled for a vector 2, and this is also an important one when you're using the invoke unity events behavior for player input. When you're using send message, you actually get a send message on performed and canceled in this condition, which means you actually get the message to stop moving the player. If you only listen to the phase, you would have received started, move to the right, performed, move to the right, and then nothing. Canceled is where you get your 0, 0. So when the action is no longer active, it's no longer being triggered, that's where you get your 0, 0 back from something like a joystick. So it's important to know the difference between these three and when and where to pay attention to them. And it really does vary based on the type of interaction you're doing. But in the example of simply passing a vector 2, you absolutely have to pay attention to performed and canceled. Okay, so moving on. What are our other ones? Jump. Create one called jump. Same idea. Get the context. This is where we get to have a little bit more fun. In our input actions asset, jump has a press and release trigger behavior. For the sake of this example, I'm going to go through a few of these, and this is where this gets a little more interesting. I'm going to remove that, so this is now a default action that you haven't added any custom interactions to. And we're going to do the same thing. We're going to debug out on jump, context phase, context action triggered, and in this time it is context dot read value, and because we know this is a button, I can just use the read value as button rather than trying to cast it down to a bool, which actually doesn't work because value for a button is a float, not a bool. So you have to write extra code. So a read value as a button is very useful as a shorthand to get back the state of a button, whether it's up or down. All right, so now we go to read our context. I'm going to push down on the space button, and we get nothing because we didn't assign it here. And this is one of, I think, the shortcomings to the current input system's invoke unity events, is that everything has to be assigned over here, or you have to write code to assign everything over here. But that's what you get for this kind of useful UI flexibility. So again, we're going to go back in, relink everything, on jump, good to go, hit play, going to hit the spacebar. We get a couple of callbacks. On started, triggered false, but value is true. So we know the event started, we know it wasn't triggered, but we know the button's already pushed down. And then you immediately get a on jump phase performed. Again, on performed is the same thing you would get from the send message function. Triggered true, value true. Then when I release, you get a phase canceled, trigger false, value false. Again, this is where in send message, under these conditions, you would only ever get one message sent, and that's the true message. You would never get the false. Unless you went back into interactions and added a press and set the mode to press and release. So now, clear those out. And again, remember we got 3 callbacks in that condition. I'm going to hit play again and do the same thing. So press, we get 2, and on release, we get 2 more. And this is really where you get into the guts of how input actions work with the interactions component attached to it. We get 2 on-performed callbacks. So in send message, you would get 2 callbacks here. In the first one, your input value would be true. You just pushed the button. In the second callback, you would get value equals false. And in both cases, triggered is true. And in the last case, you get a phase canceled, and trigger is also true because release technically triggered the action as well. So it is true that during the canceling, you also triggered it. And this to me is a little unintuitive and a bit confusing still. But I think the point of all of this is that when you listen to performed and you set your interactions to be what you want, you can very easily read, performed, value true, performed, value false. That is your definitive on-up, on-down events. So to hook this back up into the character controller, we can add something similar to this. If character controller is on the ground and context revalues button is true. And again, this is where we get a little bit into trouble, where we actually got 2 events, one started and one performed, where value is true. But this, in the context of where this was a slow press or a slow tap, started would occur, value would be true, but performed wouldn't be true until you met the requirements of either the processor or the interaction attached to the asset. So we actually also want to check for context.performed. So we want to know that the character is on the ground, the button is currently pressed, and it has met the performed requirement for all the interactions that are applied to the action itself. And once we're in there, we can set should jump equals true. And now we should have a character that actually jumps. And moves, and jumps. Okay. Last one. On hold. Same idea. This is a button, so I can just burn this. All right. And to review the input actions asset again, use has a hold interaction with a hold time of 2 seconds. And it is tied to the E key on the keyboard. And again, we need to go back in, default, add a callback context, get our function, I just realized that this is off your screen down here, but I am selecting the on hold, respectively on jump, on move actions from this dropdown. And when I hit play, and I start pushing use, we should see an event. That's the started, and then 2 seconds go by and we get a performed. And then I release, and we get a canceled. So the first one we get the moment we touch the button, that's a started, triggered false. Value is true because the button is actually held down, but the action has not been triggered. When the phase becomes performed, trigger goes true, meaning the action has now been triggered. Value is still true because we have the button still held down. And then we get an on canceled when we release the button and is no longer triggered and the button is no longer held down. So that works about the same. Hope that wasn't too bad. I'm going to do one more of these for invoke C# events, which will be a little less interesting and hopefully much shorter. And then I will do one more that is for the hardened programmer that doesn't believe in this player input component and thinks it has way too much overhead. All right, see ya.